Hello, this is Bronya. Welcome to my webinar on JavaScript. We're going to talk about objects and a class syntax. Another way how to define objects. While it may resemble class syntax from other languages, it's actually just a different syntax for constructor functions. It doesn't work like classes in other languages. So how it looks like, we had our address. Where is it? Something like this. Let's put it here to make it actually the same. This. Come on. Okay, and we have address. So we have this function address. So we can create address. We can set up x building equals 153x. City equals whatever, and we can call x get full address. Well, this is a lot of this. So there's a different way how to write constructor function. And it's like this. So it starts with the keyword class. It's a reserved word. Name of the class and then a block. You can define public properties like this and a function like this. It looks very similar. It works exactly the same. It works exactly the same, just a different syntax. What if I need something for it to do? We had our user. Do we still have user? Okay, we still have user. We had a user with some form of parameters. Set it up. Address, it's using address. Let's discard it for now. So we have x and we can call get full name. On the user, it's working. So there is something going on. It's not just definition of empty parameters. We need to somehow pass that. So how can we do this? Create class user. And we create a special function called constructor. let's take this, just get full name. This is the only thing I want at this point. It's working. So when you need to pass something to the constructor function, you actually define the constructor function and you define the parameters in it. Of course, you can do this. Still working, but it's redundant. That's, you can define the properties here in a constructor where you first use them. But what you can do, of course, is do, I don't know, this. We're not working with an email. Email is empty. It's not in a constructor, so we can actually keep it like this. Email, full name. X email, epsilon email, it's still working as it should. Epsilon y email wasn't defined, so it's default. We set up. X was already passed. So when I look at the variables, they actually contain everything again. So you're not saving, they have everything directly on them. You're not saving any space, you're not saving anything. It's really just a syntactic, different syntax on this. Sorry, just a different syntax on this. This is actually a function. It's a function. It behaves. It's just written differently, but it's a function. What you can do is this. It's still gonna work. This time the function doesn't exist directly on the object, it exists on the prototype. So when I create a different user, it's gonna have different properties, but the function will be still the same, pointing at the prototype of the construction function. So this is just a different syntax. It doesn't do anything else differently. This syntax has a lot of cool features that can be done differently with the prototype, with the construction function syntax, but it's much harder to do. We're going to explore this when we're going to talk about inheritance, but it's basically just a different syntax. One of the cool stuff that's here is a definition of a privates. So let's work with the contacts. I want a private variable. So how do I do private property here? Property that is not accessible from outside. I start the property with a pound sign. My editor actually complains, but it should not. It just doesn't know the syntax. It's fairly new. This works in Chrome. In Chrome-based browsers like Chromium or Chromium-based browsers like Chromium, Chrome, Vivaldi, Opera, new Internet Explorer, new Microsoft Edge is gonna be based on a Chromium. In a few months they will actually abandon, but it's not working currently in Firefox, the privates, as of 9/9/2019, but it's gonna. Unexpected token, where 67, okay, this doesn't belong. Must be declared in enclosing class 64. It is. What's the problem here? What is the problem here? It is defined. Okay, it's contacts, not contact. Okay, it's working. So I can call get full name. I can call get number of contacts 0. I can do contact. And I can do contact. I can call number of contacts. When we're working with the user, we were using this closure, and we were using the closure around the variable. Here you define the private on an object. It's a specific syntax. Outside of object, this is incorrect, because identifier may start only with the letter, underscore, or $sign. So this will cause an issue. Within an object, within a class definition, only this type of syntax, not in any other syntax, you can specify private and then work with the private using the pound sign. And it is not accessible from outside. I cannot do this. I cannot type. Oh, it's a private field. I cannot work with it from outside. Do contact. Do contact again. Log a get number of contacts. Well, let's do. If I try to touch it from outside, I cannot. But it's calling something, it's doing something strange. And the error is not exactly what you would suppose to see it should say something like the private fields not accessible from outside, something like that. Nevertheless, it causes an error. It's not accessible. You can only ask for it this way, but you can use it in a functions within the definition of the class as a private. As I said, this is not working in in any other browser than browser based on Chromium, but I think Mozilla Firefox should be working on it. This is a public proposal. This is for the public function. This should be already working. It's closed and it's fixed, so this is working. And the private fields, they probably working on it at this point. I cannot find the bug, but they're probably working on it. When I check for private fields, class fields, this is still as an implemental feature. There are statics. Let me type it here. I want to talk about statics as well. Public, private. You can see they're working with the private. There can be private methods as well. You can see Firefox supporting private or public. Privates are supported only what is based on Chromium at this point. You can have private functions as well, because it's a field. It's still some sort of property, just the property either contains a value, primitive value, or the property contains functions, but it's still a property. So I can have a private, let's say, get contacts function, return this contacts, and I can call it like this. It's still gonna work. Still have two contacts here because it's calling this private function, but of course I cannot call the private function. This is not a function at all. I'm trying to access private from outside. This is not gonna work. But as I've said, this is just a syntactic sugar over this. Again, I cannot do this thing in a prototype chain. I could technically do this. I hope. Not entirely sure. Yeah, I can only access it in a class definition anyway. Pretty much as you want to work with privates in a function, in a prototypal definition, in a constructor function, you have to be within the function. The same applies here. You have to be within the function. As I said, this is actually a function, just a different syntax for the function. You can mix and match, you can append what is common, what isn't private, you can append it using a prototype. So when I do what's here, I have A, as I've said, the fields exist on A and the prototype holds the getFullName function. In a development environment in a console, you can actually see the private. So the private isn't like security boundary, it's just mechanics of a programming language. If you want to keep something that should not be accessible from outside, that should only be accessible from outside through some methods that do something, manages the property, so it's not accessible directly. Like in this case, I don't want people to be able to decrease or increase the number of contacts randomly. They have to actually do the contact. I can, for example, do some logging here, do some another call, log what happened, how the people contacted the user. So this must be inside the whole process, of contacting. I don't want people to just access the contacts. We can do it through privates, either with closure or the private field syntax. But as I've said, it's only a syntactic sugar. It's called syntactic sugar, but it works exactly this way, the same way. So again, from a perspective of performance, some sort of mix match of prototypal chaining and direct go away. Okay. Still working as it should. So the combination of the prototypes and of some other syntax, whether it's constructor function or the class syntax, provides the fastest creation of the object with least memory. It looks weird tying those two things together, especially for people who come from other languages. I still think it's weird even if you don't, because you declare something within the class declaration and you declare something here. It's just weird. By the way, this is actually class expression. It's not a class declaration. Cannot access class before initialization. We've seen it. If it was a function, function declaration, this would actually work. The function exists, I can run it, I can work with it, I can do okay, I have user2 object because this gets hoisted. Well, this doesn't get hoisted. This is actually equal. There's a reason why although one can say, okay, this should be like class declaration, so we should be able to hoist it the same way as we hoist this. And when user 2, it works. If I turn it into class expression, function expression, it's not working. We're in the temporal dead zone here. So someone can say, well, this should work on a class declaration, quote unquote, and there should be some sort of class expression. There is a reason why both of it is actually an expression. There is a reason for that. So the class doesn't get hoisted. The reason has something to do with inheritance. Although you can do inheritance using functions, you will understand what I mean once you see it. So this is another way how to declare objects, how to create a construction framework for an object. So let's talk a little bit more about objects in general. Let's keep this. User, I like the user, it's a nice class. Okay, let's have the address. Let's work with the address. So we have our address class. There's an object called okay, should I talk about this first or this first? Let's talk about this first. By default there's an object called object. It's a function actually, and similarly as a number it turns stuff to object. I actually get an object number. We're gonna talk about it. There's a difference between number 5 and object of number 5. If I do this, it's not equal. One is a primitive value, one is an object. I'm gonna explain why it's so weird. You can also create object actually using object as a constructor. Similarly as I can use address as a constructor, and I can type I have to refresh it so I'm not declaring the same property over and over again. This is just clearing. So this is empty object. When I touch X, it's an address. Epsilon is an empty object. It's the same as if I would write this. Z. It's exactly the same. This is a literal. This is a construction call. The result is the same type of object. By the way, comparing objects, I said the same type of object, not the same object. It's false. You're comparing it by reference, again, not by value, which means I create this object, which is some memory, and this is a different object in a different place in a memory. False. This is still false because it's a different piece of memory. So again, you're comparing by reference, which means you're comparing by what's in the memory, not by a value. It doesn't have a value. There is no like inherent primitive value that it can be converted to. Although okay, it can be converted to string, of course, or not. Of course, I'm going to show you. But when you're working with objects, it is comparing by reference. So we had a type of. So we know, for example, we can check when we have a okay, let's refresh the page. And we can ask type of X. Okay, it's a number. We know it's a number. Type of Z. It's an object. Okay. Type of A is object as well, but those are different types of objects. So there's another operator called instance of, and that's for querying objects. So type of is for querying mostly primitives, maybe functions, if you want to know what's function, because you get type of function, you get a function, which is great. For querying objects, there's an instance of. It works differently. Type of has a one parameter, instance of has actually two parameters. So I can ask that instance of address. Well, it's true. A instance of address is false. That is actually instance of object. That is actually true. It has something to do again with inheritance. We're going to talk about inheritance. Everything is an object. And everything inherits from object. We haven't talked about inheritance yet, but we can. So let's do more things with Z. We have a Z. And we want to check out the properties of Z, all of them. There's a for loop for that. We haven't talked about the for loop for objects yet. We were using for loop in those three stages: the initialization, the condition, and the end block stage. There is a for loop for Z, for let prop in Z, console log prop. Those are all the properties in my address, in my address object. Well, I still get full address. Although it's in a prototype, I still get, when I check new address, it's in a prototype actually. I still get it. I don't like that. If you want only, by the way, you can see that this is this time in the same order as it's defined, but as I've said, don't count on it. If you want only the properties that belongs to that object, you can query it. Let me put it this way. Don't care. Let d equals new address for property in D. So you're declaring property and you ask about the property, not the value of the property, but the property itself, the name of the property. It has D has on property, so if the property is directly on that object, let's console log, for example, property and the property. Let's use the computed member access. D type street equals my street. The country equals Czech Republic. I type it. So the in operator, again it's an operator, we already know about it. That's true. That's false. There is another way how to utilize it in a for loop, when you can go through all the properties you get, and you can, if you want only the properties on that object, you can use has on property. This lists everything. The object, we still have Z. I cleared it. What was it? D. Okay, we still have D as an address. Yeah. The object, where was it? Has a lot of methods directly on it, so-called static methods. We're going to talk about how to create static methods. You don't call static methods on an instance of an object, on an, for example, D, which is an instance of an object. You call it on the class, sort of, on the constructor function. For example, it has well, it would return array. We don't know about arrays yet, so we're gonna talk about it probably after array. Yeah, we'll stick with the has own property for now. We're gonna talk about the rest probably later. I can mention the object is, that's a nice addition. You can compare two values using object is. It's a comparison. The interesting thing about this comparison is -0 equals 0. Well, that's true. There are actually two zeros in JavaScript. You get one from this, and you get the second one from this. Two zeros. And although mathematically they should be pretty much equal, two distinct values, and we also know that none, this returns false. It's a special value. The object is actually work as it's supposed to work. Those are false. This is not true. Those are distinct values. Although mathematically they are the same, from the purpose of the language, they're different. And you can get object is true. So let's talk about more the converting the primitive values to object. So I get, let's say, let's let x equal some text. Okay, x is just some text. You can force it to be an object using the access operator. You can actually force it to be an object, and you can query the x, although it is a primitive value. This operator force it into an object, and you can call the length. Well, it's 9 characters. Z, x in this time is a primitive value. This is forced into an object that's indexed, which means, well, I can query something like this. So it's indexed from 0, 1, 2, 3, 4, 5, and it has a length. So I can actually query the string object, turn it into something else. Okay, and a string has a bunch of methods, either directly or on its prototype. If it's on its prototype, you can call it on a value, on a set. If it's not on a prototype, you have to call it directly. String dot from hardcode. Well, it's actually decimal. So decimal 65 is big A. We already know that 41 is big A. Hexa 41 is actually decimal 65. 4 times 16, 64 plus 1, 65. We know how the conversion works. We talked about it. So you can actually work with strings using a bunch of methods. I'm not gonna go through every single method for every single type of object. The point isn't to remember, okay, there's like 50 methods for strings and 30 methods for numbers and a bunch of methods for objects. The point is to remember that they exist and just find them. This is not a memorization. No one's gonna be yelling at you what exactly string replace do. But you can know that there are functions on it that do stuff. You can read it and work with it. For example, Let's look at hardcode add. Hardcode returns an integer between this and this, representing the hardcode. Oh, let's check it out. So we have a string, let x equals some text, for let I equals 0. We already know we can query the length, and the length is from 0, the index is from 0 to length plus 1, length minus 1. Already seen it. Check x. So there are properties with the numbers from 0 to length minus 1. You can just write it. That's just the index. It's a property. So let's do computed access for the property. We have all the characters. So those are decimal representations of the characters in some text. 83, 111, the space is 32. You may know it if you press Alt on your keyboard, left Alt, and type something on a numpad on your keyboard. You get a character. So if I press Alt, type 65, release Alt, I get A. That's the 65. So if I do 83, I get the S. I type 111, I get O, some text. So there are a lot of functions for manipulating, for example, text. There are some nice, like trim. People often use it. Okay, access already exists as usual. Let's say you want to remove the white spaces at the beginning or at the end. The white space can be enter space and other special characters that create white space. So we can do this. Z remains blah. But if I do this, Y is the trimmed character, the trimmed text. When I remove the surrounding white space, only, by the way, the surrounding, not all of it. If I create white space in between, I just get what's outside. For example, you have index of, for example. Let's stick with our some text, and let's ask x index of O. It's 1, as I've set it, index from 0. 0, 1, 2, 3, 4, 5, 6, 7, 8. Oh, if I ask for E, I get a 3. 0, 1, 2, 3. If I ask for A, I get -1. If it doesn't exist, it's -1 because it starts with a 0. I can say a position from which to count, which means this is at index 3. This is the first, but I want to count from index 4. So I can do this. If I want all the indexes, for example, again, I can do a lot of things with this for what will happen if I do this? It's the same, okay. For let e equals 0. And what happens if I ask for this -1? Okay, so this should work. And do nothing at the end. For example, like this. Why not? Let pos equals x index of, we were talking about letter E. If pos, and let's start from I. If pos is -1, just break out. Else console, I don't have to write else here because I'm breaking out anyway. I can do write else here, but I'm breaking out anyway from the cycle. This may be a little bit better to understand, but it's not important. Okay, so letter A is at indexes 3 or 6. So I'm going from index 0 up to the length. I'm asking for the position. If I know the position, if the position is -1, I just break. Otherwise, I type the position and I set up the I. There is nothing here at the end. I set up the I as position 1, as a position +1, because index of returns the first occurrence of the specified value starting the search at from index. Search value from index. From index, if it's undefined, it starts from 0, including. So I know, for example, this is 3, this is still 3, starting from index 1 would be letter O. This is still 3, starting from 0, 1, 2, 3. Okay, it's still 3, so I have to actually increase it by 1, and then I find next. If I don't find any, it returns -1. So I can go through the string and just do it this way. I can do it differently. I can do it, every cycle can be rewritten by pretty much any other cycle, or most of them. this. What have I done? Okay. We write the code correctly here. Console log pos. I can do it like this. I can do it like this, else please break. While true. Looks like it's running forever. Yep, it's running forever. Let me check it out and rewrite it. We start with this one, index of and position 0 becomes the position, which is 3. Should type of 3. From the position 4, this should become 4. Oh, 6. This should work. -1. Okay, it's working actually. So this is a different way how to write all the position of letter E in the text. Again, it's worked the same. I start from number 1 and I'm asking position from 0, which will return 3. That's bigger than -1. So it writes down 3. The while cycles goes forever. Starting from position 4, it's gonna be 6. So 6 is gonna be written starting from position 7. There isn't one, return value is -1. It breaks, still works. I can do this as well. Works. Okay, this is running forever. Yeah, when you're working with cycles, you have to put -1. So this returns 3. Then it should return 6. Then it should be -1. Okay, of course that should be -1. It's just a typo pretty much. The cycles can be written different way. But you can work with strings. So we can do, let's replace something and let's skip regular expressions for now. Can we replace what's first? First is a substring, which is, let's say, me, and replace it with big me. So a replacement on the string. So there are a lot of methods you can utilize to work with primitive type string that you don't have to do. Or substring, I think this should be, yeah, substring. This is just a legacy. So you can run substring 1, this is length of count, no, it's index n, which should return also everything from index 1 to index 3, up to index 3, not included. So if I do this, if I do this, not included the index. Or if you omit the index, the end index, it just takes everything from index 3, 0, 1, 2, 3, takes up everything. Make it bigger. It doesn't work with negatives in an index start. Apparently some of them do. Some of them should. Apparently not on strings, on arrays, probably they do. So there are a lot of methods how to work with strings. For example, I can do the local uppercase. There is a, for example, to uppercase. Let's check out the uppercase. It's Mozilla. Okay. It still works. It can work even on this. This is still better. To uppercase works with, where is it? Uppercase converts it to uppercase if it can be done. But it doesn't necessarily work perfectly with locales. It works here because I'm on check locales on a computer. So to locale according to any specific case mapping. You can see it here. Local uppercase. It looks slightly differently in Turkish than in US. As I've said, a lot of functions. There's of course for numbers as well. Is finite, is integer, is none. Okay, there should not be necessarily. Yeah, they are on numbers, they are on window as well. For example, we can check out the fix. There is a number of decimals you should get from the fix. It's called parse float. Well, it's way too complicated to fix. Let's do it this way. This is gonna look weird, but actually you can do it. It's to two numbers. It looks weird, but it actually works. When you need to work with, when I do this, it actually, when you want to work on a regular integer, you have to work like this. It still does to fix decimal points. Of course, this works perfectly as well. the reason for this is because, well, there should be a decimal part, because when parser goes, when JavaScript goes, it says, okay, this is a number, this is a decimal part, and I don't understand what this is. It has nothing to do with the decimal part. So you actually do something like this, or you can do this, or you can just do this. Let's do precision. Which apparently gives exponent. Why does it do it? Go this. It gives the precision to two numbers, which is actually 12 here. If I get to 1, it would be, this should be enough. As I said, this is exponential notation for will be forced. Can I force it to something? I actually cannot force it. But this is the precision to one number, which is 100. 1 times 10 to the power of 2. If I do for 2, it's 5.2 times 10 to the power of 2. So it adds actually. So there are again functions you can do on numbers, parse it, compare it, non-finite, integer of course. Again, this is not called on prototype. If it's called on prototype, you can call it on a number itself. This is not called on prototype, so you have to call it pretty much like this. It's false. This is true. Basically, if it exists on prototype, you can call it on an object itself. We talk about it. If it's not a prototype, you have to call it on a class, quote unquote class. It doesn't exist on prototype. It's actually a static method. We're going to talk about statics. So there are predefined objects, and using the methods on those objects, you can manipulate them, you can query them, you can work with them. It's actually number epsilon. This number. Well, what it means, we talked about it, by the way. I showed it. Well, that doesn't work exactly as we want. Let me do this. 0.3 is smaller than epsilon. Well, we get true. Epsilon actually is the smallest floating point number greater than 1. What it means is that since this goes overflow, you can actually do a comparison. Normally you would do something like this, but this doesn't work in JavaScript. It's false. You can do the comparison actually like this. You do the division, and the division actually something like this must be smaller than the epsilon. I'm not going to explain mathematically why. What does it mean smaller floating point number greater than 1? But this actually works. And we're going to talk about a lot of those objects, a lot of those built-in objects next time. There are a lot of them here relate to actually HTML. There is nothing like do they all exist? Apparently they all exist. Okay, there are others. Yeah, they all exist. So we're gonna talk about them in the next lesson. I'm sorry it's getting a little bit here and there and here and there. The problem is that the subject of objects is very complicated, and you can go in different direction how to talk about objects. We haven't talked about inheritance yet. I might have, without getting here to this point. So some of the things I'm talking about are not necessarily obvious immediately. Why there is a number is finite, a number dot prototype dot to fix may be a little bit confusing, but it's all about learning. So thanks for watching, and I'm gonna see you next time. Bronya is out.